Okay, so I may have lied to you a little bit at the end of the last video, and that this is not going to have number 6. This video is going to be just numbers 3, 4, and 5. Number 6 is definitely the most challenging problem on here, and I'm going to do it in its own video. That way, if you need to watch it more than once, you don't have to watch the entire thing again. So, thinking about what we just did is we're setting our two factors equal to 0 and using the zero product property to solve. So if we look at number 3, we've got p squared plus 8p plus 7 equals 0. It's already equal to 0, so we don't have to do that. But we can look at this left-hand side and see that it's just a diamond problem. So if we set up our diamond, and the way we know it's a diamond problem is that our leading coefficient out here is a 1. So remember that the constant goes in the top, the coefficient on the linear term goes in the bottom, and we multiply to 7, add to 8. So what two numbers multiply to 7 and add to 8? Well, it's going to be 7 and 1. So that means our factors would look like p plus 7 and p plus 1. But we're actually solving this equation, not just factoring it. So now that we've got two factors multiplying to be 0, we know we can set each of those equal to 0 and solve. Those equations don't look terrible. So we get p is -7 or p is -1. So if it's straight to the diamond, you pull your values over. That lets you find your factors, and then make sure you're setting your factors equal to 0 and solving. Number 4 looks like it's going to be a straight to the diamond problem, except you'll notice we do not have 0 on the right hand side. So we can't use the zero product property until they're set equal to 0. So that means the first thing we have to do is get that right hand side to be 0. But we can do that by subtracting 2 from both sides. So if we subtract 2 from both sides, we get n squared minus 4n minus 32 equals 0. Because if we subtract 2 here, 2 minus 2 is 0. Negative 30 minus 2 is negative 32. And now we can do our diamond problem. So if we set up our diamond, it's going to be negative 32 in the top, negative 4 in the bottom. We're multiplying to be a negative, so that means one of these is going to be negative and one of these is going to be positive. So what two numbers multiply to negative 32 but add to be negative 4? Well, it's going to be negative 8 and positive 4. When you're doing these, please check what you're getting in your diamond in a calculator. Multiply negative 8 times positive 4, make sure it's negative 32, and add negative 8 and positive 4, and make sure it adds to be negative 4. Don't make silly mistakes just because you didn't check your work. This lets us get our factors, n minus 8, n plus 4. And again, remember these are equations now, not just expressions. They're equal to 0. So now we've got two factors that multiply to be 0. So we can set each one equal to 0, because the zero product property says if I multiply two things to be 0, one or both has to be 0. So these equations aren't bad. If we add 8 to both sides, we get n is 8. If we subtract 4 from both sides, we get n is negative 4. So the only key or the only extra step we had to worry about for number 4 was that our right hand side wasn't equal to 0. That is something you need to check every single time, because if it's not equal to 0, the zero product property won't work. Okay, let's look at number 5. And then, like I said, I'm going to do number 6 in its own video so that if you need to watch it multiple times, you don't have to sit through all the other problems. So, number 5, if we look at this, we see that our leading coefficient isn't 1. So we're thinking right away, oh, this is going to be a harder diamond problem. Before I worry about that, though, I go ahead and look at the right-hand side and see that it is equal to 0, so I don't have to move anything over, so that's good. But before I start worrying about those harder diamond problems, what I want to think about is everything here divisible by 3? Meaning, could I use that greatest common factor idea to get an easier diamond problem? And in this one, we can. So, Skylar, that's for you. I just said can. If we divide every term by 3, we get b squared plus 4b plus 3 inside our parentheses. And that's what we're going to use our diamond problem for. So what's inside these parentheses is an easier diamond problem, our straight to the diamond. So we get 3 in the top, 4 in the bottom, and we want two numbers that multiply to 3 and add to 4. So we get 3 and 1. If we bring that over here, we're going to have our 3 on the outside. We have b plus 3. We have b plus 1. So now we've got our factors that are multiplying to be 0. So we set each one equal to 0. And then those equations aren't terrible to solve. So subtract 3 from both sides, and b is negative 3. Subtract 1 from both sides, and b is negative 1. So don't forget that idea of greatest common factor, because if you're able to divide everything by that leading coefficient and set it out front, you're going to get an easier diamond problem, and we like those better than the harder ones. Okay, number 6 is going to be its own video in just a minute.